Hello, we're going to look today at differential equations again. So our second look at exercise 13C with Year 13 Maths. And we're doing it because it's quite a tricky topic. It's one of those that always comes up and it always catches people out. So don't be surprised with seeing them twice. And of course, the last time we did this, we were looking at trying to make differential equations from some kind of real life example. So I'm going to do a few more like that. And this is particularly like what we've seen in the past because it's talking about forces as well. And if you might remember, for instance, there was this formula that said this is Newton's second law, F equals ma. We're going to use that one to solve this problem. And the other one I've kind of put over here, I've said that the acceleration, you get the acceleration by differentiating the velocity with respect to time. So a equals dv by dt is equally important. So those two formulas I think we're going to end up using quite a lot. Well, at least once each. A milk float then anyway of mass 800 kilograms starts from rest. As soon as I see starts from rest, I'm thinking to myself, that's what you'd call an initial condition. It starts from rest, t equals 0, when the v equals 0. So just bear that in mind. We might need it later. We might not, but we might do. With the driver applying a gradually increasing accelerating force. Now that would be easy to miss that. Look, it's not the acceleration. It's an accelerating force, and that's why we use this F equals ma. But anyway, it's given as this, so I'm just going to write this at the bottom. F equals 60 root t, and of course 60 root t is better written as 60 t to the half, I think, because I suspect I'm going to have to integrate or differentiate. In fact, before I do any of that, it does say that the mass is 800. So if the mass is 800 and F equals ma, you can see F equals ma, and I probably will want the acceleration because it says form a differential equation and solve it to find how long it takes to reach a speed of. So I want the velocity. Before I can find the velocity, I'm going to need an acceleration. So F equals ma, so there's 60 t to the half equals the acceleration, the mass was 800 times by a, and so by definition a equals, move the 800 over, it's 60 divided by 800. So just get the calculator out, don't want any daft mistakes. 60 divided by 800, 3/40. So 3/40 of t to the half. Now that's the equation for the acceleration that I will need to use. So let's go over here. A said 3/40 of t to the half, and of course what I can do is set this a equal to this dv by dt. So dv by dt equals 3/40 t to the half. Now this is one of those easier differential equations where you separate the variables, yes, but effectively there's no v, so I can just think of this as moving over and becoming an integral of dv equals the integral of 3/40 t to the half dt. Add a power, it's 3/2, so it's 3/40 to the t to the 3/2, but I've got to divide by that, so that's the same as times them by 2/3, and that's handy. Those thirds go, the 2 and the 40 will disappear. I end up with obviously a 20th t to the 3/2, but I've got to be a bit careful, plus a constant. The left hand side is v. So of course these did say it started at rest and stuff like that, didn't they? So t equals 0 when v equals 0, that was our starting initial conditions. So I've chucked that into there, therefore 0 equals a 20th times by 0 to the 3/2 plus a constant. Now the only thing is that's going to be equal 0, so therefore c equals 0. So my equation now is a v equals a 20th t to the 3/2, and I've got no plus c at all because the c's gone. What do they want me to do then? When does the speed get to 10? So I can just say that 10 equals a 20th of t to the 3/2. Move the 20 over, I therefore get t to the 3/2 equals 200. And presumably t is 200. Move the 3/2 over, you get a power of 2/3. 200 to the power of 2/3 equals 34.199, so at 34.2 seconds, I'm going to say. Hopefully that's right. 34.2, good. Next question. A skydiver of mass 60 kilograms jumps out of an aeroplane. He's got, obviously, when anyone jumps out of a plane, they're going to have a weight pulling them down. This is a bit like some of the mechanics we did last year. You've got a weight pulling them down. What's their mass? Their mass is 60. The air resistance, alright, they're being slowed down. There's a force pushing them back, well, not pushing them back, but slowing them down. It's proportional to the velocity and may be modelled by 0.8 v. So that's going that way. Okay. Using g to be 9.8, so therefore that's 9. Right, do I get told? Yeah, I got told it's 60. So if you remember the formula for the weight, it's mg. So in this case it's 60 times by 9.8. Just do that, 60 times by 9.8, I get 588. So W is 588. So I suppose what I've got here is that the rate of change, the acceleration. Well, let's do the forces first of all. F equals ma. That's the forces, and I've got a force of 588 minus 0.8 v equals the mass, which was 60 again, times the acceleration. And I want to change that a actually to dv by dt. You remember before I had a equals dv by dt. The last time I had these two equations acting. And already I think I'm going to be using both of them in this question as well. So well, I could move the 60 over, I suppose. A equals 588 minus 0.8 v over the 60. I could tidy that up a bit as well. Let's do 588 divided by 60. And it's just 9.8. Well, probably it had to be. Our times it by, yeah, had to be. A equals 9.8 minus, and this is the more interesting one, 0.8 divided by 60 is a 75th of v. Now remember, A is dv by dt equals this. And so perhaps, I hope I've got another slide I can move this onto. That's my formula so far for dv by dt. The question is, oh, this gives me an extra question. I'll worry about that in a bit. So I've got dv by dt equals, and it said 9.8 minus a 75th of v. Of course, what I need to do is move this little lot over to there and move the dt back again. So that would give me the integral of over v dv 9.8 minus a 70, what was it? 75th of v is equal to the integral dt. Now on the right hand side, easy, that becomes t. The left hand side, it's got to become a log presumably. And because it's over this minus a 75th, I think it basically becomes minus 75 log of 9.8 minus a 75th of v. Oh, be careful, I've got to put a constant there as well, plus a constant. I don't like the way it's written, so I'm just going to tidy that up a bit. Minus 75 log 9.8 minus a 75th of v plus a constant. Now, did I get told some initial conditions? I'm trying to remember now. We had jumps out of an aeroplane with 0 initial velocity. Okay, so presumably t equals 0 when v equals 0. Put that into my equation. 0 equals minus 75 log. Now v equals 0, but not all. So I think that's log of 9.8 plus a constant. So I think I need to work out what that is. Negative 75 times by the natural logarithm of 9.8. Very nice. Move it over, I get c equal to 171.18, give or take a bit. what's the question asked for? It says, write and solve a differential equation to find the expression for the velocity. Well, I think that's more or less it then. The expression of the velocity, apart from that, I've got t equals. So let's rewrite that. T equals minus 75 log of this horrible thing. Plus, well, I could write this as 7. I might write it like that for now. It might be better like that. If I move this up here, I can move my those round. That gives me 75 log 9.8 minus a 75th of v is equal to 75 log of 9.8. And as soon as you see that, oh no, I was going to say that's moved over minus t. So I suppose I can divide by 75. That makes life a bit easier. I've got log of this and log of that. So why I join those together? So does it give me the log of 9.8 minus a 75th of v divided by 9.8 equals minus t to the 75. So move the log onto the other side. I get 9.8 minus 75th of v over 9.8 equals e to the minus t over 75. That obviously doesn't disappear. It becomes 1 minus, what's a 75th divided by 9.8? Can't imagine it's very nice. 1 divided by 75 divided by 9.8. 1 over 735. V equals e to the minus t over 75. So switch those round. I've done a lot of switching. I reckon there's probably a better way to have attacked this. What am I getting there? I'm getting 1 over 735 v equals 1 minus e to the minus t over 75 times by 735. V equals 735 minus 735 e to the minus t over 75. I've got an answer somewhere. Yes, that's the same thing. Correct. After all that, it was right. Did they ask for what was the terminal velocity? Now, terminal velocity says if t is really, really big, if eventually, what will happen to your speed? And basically, in this case, if t is big, this e to the minus t over 75 goes to 0. This gets closer and closer to 0 as t gets bigger and bigger and bigger. So effectively, that whole thing's becomes 0, and therefore the terminal velocity just becomes 735. This bit will all disappear. So that's the second bit, and that's it. That's what they've said as well. So good. I don't think I'm going to have time to do that. I've got this third question which I'll do in class, but I'll leave that till then. For now, we'll just leave it just noting the fact that we've got a few questions from exercise 13C to do. Hopefully, after 2 bashes at this, 13C.1 and 13C.2, we'll be okay and we'll be able to do them. I've got lots more questions for you as well, so best of luck.